Howdy calculates, section 3.2. Okay, so the first thing is I want to make sure that you are pronouncing this correctly because pronunciation always bugs me. So French people, you have a little bit of an advantage because this mathematician was French. So his first name was Michel and the last name is pronounced Roll. 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 Okay? Okay, so extreme value theorem says that a continuous function must have a maximum and minimum if we're on a closed interval. So that means I'd have dots at the endpoints. Again, but that these values could both be the endpoints. Oop, typo. Just fix the typo. I can't fix that. I figure you know how to spell endpoints. Anyways, kind of obvious because we've been talking about this already. And of course, in our tables, we've actually put in the endpoints, right? Because it's possible that the maximums and minimums occur at the endpoints. So, like over here, well, I don't know, that's probably a bad example of, so let's say I put it, the right endpoint here. So then certainly this left endpoint, pretend that I actually hit it, is the highest, although oh man, I should have made that over a little bit farther. Let's pretend that I did. And let's say that so the minimum, well, I still missed it. I wanted it to be in here. I really suck with this pen. Okay, so you get the idea. That's why we've been looking at the endpoints. Okay, so Rawls' theorem says if I have a continuous function, so again, I can't pick up my pen. Struggling on spelling too. Whew, I can't write, I can't spell. So continuous and differentiable. So in other words, I can find the slope of any tangent, differentiable, on the open interval AB. So now here's why I'm turning it into open, because remember, to be differentiable, I have to be able to swoop in from the left and the right and get the same derivative value. And if it's open, I can do that. If it's closed, I can't, because I can't swoop in from either the left or right. Keep in mind, we'll do this up here, that as long as when I draw this, it's open, then technically I can still swoop in from the left because you know, it's like just a little bit inward, and I can get the derivative of that left endpoint. And technically, I can swoop in from the right because well, it's not at the very end, right? It's a little bit in from it, so I would be able to find the derivative a little bit farther in, if you know what I mean. Okay, so then, if f of a equals f of b, so in other words, the y values for the beginning piece and the end piece are the same, then somewhere in between there I have to have a x value where there's a turning point. In other words, the slope would be 0. And so I want you to think about it like this. Apologize for all the little minifigures. So if I have this continuous continuous function, and it's differentiable, and I notice that here's a pair of y values that are equal, then so this would be a and this would be b, so f of a equals f of b. That somewhere in between I had to turn around, otherwise how would I get back up to this point again, right? So it makes sense that I had to turn around, which means the slope of my tangent is 0. It seems so obvious. How come he got credit for it? I could have figured that out.